Alright, so here's a quick review of Lesson 3.1 notes from class on Thursday. Our goal is to find the solution to the two-variable system by graphing. The solution of a system of equations is the one-ordered pair that makes both the equations true. So we're looking for an ordered pair that we can plug into both equations and would make it true. So when we graph, the solution of a system of equations is where the two lines intersect. So if we look at the equations we have here, we have y equals negative x plus 4. So we start at 4 and we go down 1 over 1. We have y equals x plus 2. So we start at 2 and go up 1 over 1. So the solution is this point where they intersect, and that point is 1, 3. So one of the things we want to do is we want to be able to check our solution. We want to check and make sure it makes both equations true. And so what we're going to do is we're going to plug 3 in for y and 1 in for x. So we end up with 3 equals negative 1 when you plug 1 in for x, leaving the negative sign there, plus 4. When we look at that, negative 1 plus 4 is equal 3. That's a true statement. We're going to plug 3 in for y, 1 in for x. So we have 3 equals 1 plus 2. 1 plus 2 does equal 3, so that is a good solution. So that's what it's going to look like, reading solutions from a graph and then checking them. But what we want to be able to do is to actually graph. So we have the equation y equals negative x minus 2. So we're going to start at negative 2. And then what we're going to do is go down 1 over 1. Now we don't know where that solution is going to be. And so we need to keep counting our slope down 1 over 1. And we need to do that as accurately as possible. So we're going to go down and to the left, but then I'm going to count to the right. So I have to go up 1, back 1. And we're just going to keep putting the points on there. To make our line. And then we're actually going to connect them with our line. So we'll go through and draw the line that connects those points. So we've got our first line on there. We now need to graph y equals 2/3 x plus 3. So we started our y-intercept, or constant. So we start at 3. And we're used to counting our slope, so we go 2 over 3. I can see that we're obviously not going to intersect anywhere on this side. So I'm going to stop counting to the right. And so now what I'm going to do is I'm going to take my slope and I'm going to go down 2, back 3. And what we can actually see is that we found our intersection point when we place that. So I'm going to draw my line. And so what we have now is we can see that our solution is this intersection point, and our solution is going to be negative 3, comma 1. And so what you can do is take and plug that in. So we would have 1 equals, we'll have negative 3 minus 2. If we look at that, the opposite of negative 3 is 3, and 3 minus 2 is 1. If we plug it into the second equation, we're going to have 1 equals 2/3 times negative 3, and then plus 3. If we do 2/3 times negative 3, that's -2, and -2 plus 3 is 1. So we can see that by graphing and checking that answer algebraically, our solution is -3, 1. Now sometimes we're going to have to solve for y before we graph. We have used standard form graphing of using x and y intercepts before, but because we need to have accuracy in our graph, what we need to do is have as many exact points as possible, not just a rough sketch of the line. So what we're going to do is take 2x minus 3y equal to 1 and subtract 2x. And so we have -3y equals 1 minus 2x. And then what we're going to do is divide by -3. And so we get y equals +1 divided by -3 is -1/3. And then -2 divided by -3 is a +2/3 x. So I'm going to start at -1/3. So what I'm doing is putting my point. It is kind of an estimate, but I'm kind of keeping it closer to 1/3 than 1/2. And now what I need to do is count up 2 over 3. So when I do that, you're going to see I'm going to go up 1, 2, and then over 3. I'm no longer on the actual grid line. I've taken -1/3 and I've gone up 2, which is 1 and 2/3. I'm going to do the same thing again. Count up 2 and then over 3. I don't know where these two lines are going to intersect, so then I have to go down 2, back 3. Still, once again, making sure that my points are at that 1/3 position. So I'm going to take my line and connect those. If you look, even though we didn't plot any points at exact integer ordered pairs, our line still goes through, so I feel pretty confident I've got a couple of good spots for an intersection point. I need to graph x plus y equals 3. So to get y by itself, I subtract x, so that y equals 3 minus x. So we're going to start at 3, and then we're going to count that negative slope of 1. So that means I go down 1 over 1. I'm going to go from that point, I'm going to go down 1 over 1, and in fact we do hit right there. So I'm going to draw on that line. And we can see we have our solution right there. So our solution is 2, 1. Now we can check that solution. So we would have 2 times 2 minus 3 times 1. And we're going to see if that equals 1. So if I look at this, I have 4 minus 3 does equal 1. If I check it in the second solution, I have 2 being substituted for x, 1 being substituted for y. And so when I look at that, 2 plus 1 is equal to 3. So even when I'm graphing these fractions, I still know to find nice integer ordered pairs. And that's when we use graphing, is when we're going to have nice integer ordered pairs. Now what we want to do is do a little bit of review from what we learned in Algebra 1. There are different types of systems. Some systems have infinitely many solutions. We learned that as IMS is what you're going to recognize that as. Okay, and we'll still use that as our abbreviation. But infinitely many solutions is when you have the exact same line, you have the exact same equation. So what that would look like is I would go through and I would graph one line. I would graph one line, and then I would graph a second line right on top of that. And so we end up with the exact same line, the exact same equation, we end up with all of these ordered pairs along that line that are all solutions. And so that's what infinitely many solutions look like. No solution, we can, I'll see if I can draw this by freehand. We do the null set, so our circle with a line through it. So we've used that for our no solution. But no solution is when we have parallel lines, meaning that they have the same slope but different y-intercept. If we have parallel lines, if we think about what those were, we had a parallel line where we maybe started at 4 and went up 1 over 1, and then we started at -5 and went up 1 over 1. When they were the same slope, they were the same rate of change, they were never going to intersect. And so if there's no intersection, that means that there's no solution. And then what we looked at in our two examples that we grabbed were what it means to have one solution. One solution is where we graph one line, graph a second line, and then the ordered pair where they intersect, this point right here, that is our one solution. And so we name that ordered pair. So one solution looks like x comma y. We name that ordered pair. All right, so hopefully that was a nice quick review of graphing systems of equations.